Good morning, students. The topic for today's lecture is hydrogen bonding. Hydrogen bonding is covered under the topic chemical bonding. This is a special topic studied under a separate heading. So in today's lecture, we are going to concentrate on the definition, the characteristics and the type of hydrogen bonding. First of all, hydrogen bonding definition. Hydrogen bonding is called a bond, but it is just a weak force of attraction always between an electronegative atom like fluorine, oxygen, nitrogen and that of hydrogen. So the basic requirement for hydrogen bonding is always an electronegative atom. The most electronegative from our periodic table is fluorine, followed by oxygen, followed by nitrogen, and always there will be presence of hydrogen. So it is just a weak force of attraction between an electronegative atom and the hydrogen chemical circuit. Am I clear? In this diagram, I am going to explain you the weak force of attraction between an electronegative atom, that is oxygen, and the hydrogens which are considered as electropositive. In a bond between hydrogen and oxygen in the water molecule, the oxygen is gaining a partial negative charge and the hydrogen is gaining a partial positive charge. It means that the electron between the hydrogen and the oxygen is drifted more towards the more electronegative atom. The hydrogen bond is always represented by a dotted line, whereas our stronger bonds like your covalent bond and ionic bond are always represented by a complete line. Am I clear? So wherever we are representing the hydrogen bond, it should always be with respect to the dotted lines. Now we come to the characteristics of hydrogen bond. This is also very important for your examination, 1 or 2 mark question. What are the characteristics of hydrogen bond? So as I told, for hydrogen bond, the basic requirement is presence of an electronegative atom like fluorine, oxygen and nitrogen, and the second basic requirement is always the presence of hydrogen. Am I clear? Next point is, it is a weak force of attraction but not a chemical bond. So our chemical bond is basically of two types, the covalent bond and the ionic bond. Your dative bond or the coordinate bond is a special type of your covalent bond. But your weak force of attractions include van der Waals force of attraction, the hydrogen bond. So we can say that it is just a force of attraction between a positively charged atoms or the ions, but it is not a complete or stronger bond like covalent bond. Because it is a weaker force of attraction, it is always represented by a dotted line. Am I clear? Second point is, it is stronger than van der Waals force of attraction. As I told in the previous class that within all the materials which are present in the space, there is a strong or a weaker affinity between them. So that is represented by van der Waals bond, which was given by the scientist van der Waals. So hydrogen bond is stronger than van der Waals bonds, but it is weaker than covalent bond and ionic bond. That is why it is represented by a dotted line. Am I clear? The third point is, the bond strength of hydrogen bond is generally weaker than the covalent bond and it lies somewhere between 3 to 10 kilocalories per mole. It means that in order to break the hydrogen bond, we require very less amount of energy, that lies between 3 to 10 kilocalories per mole. But for covalent bond, the bond strength is stronger. That is why the bond energy required to break the bond is going to be more comparatively as compared to hydrogen bond. Am I clear? I am repeating once again. The bond energy, that is the amount of energy required to break the bond for covalent bond and ionic bond will be greater than that of the hydrogen. Next point is, strength of hydrogen bond depends on the electronegativity of the atom attached to it. You know that fluorine is the most electronegative atom in the periodic table. So the bond between fluorine and hydrogen is stronger than the bond between oxygen and hydrogen, is stronger than the bond between nitrogen and hydrogen. It means that because fluorine is most electronegative, it forms the strongest bond, followed by oxygen and hydrogen, followed by nitrogen and hydrogen. It says that indirectly that fluorine is the most electronegative, followed by oxygen, followed by nitrogen. Okay, next is, it is a weak force of attraction but affects the physical property and chemical. It means that hydrogen bond is an additional bond than the covalent bond and the ionic bond. So it changes the physical property of a compound. For example, the boiling point of water is more because it has additional bond, that is the hydrogen bond between the electropositive hydrogen and the electronegative oxygen. So more the bond strength of hydrogen bond, it will affect directly the strength of the hydrogen bond. Am I clear? So more energy is required to break the bond. Next is Also, it is sometimes seen in the molecule which contains chlorine and sulfur. You know that the most electronegative is fluorine, followed by oxygen, followed by nitrogen. But these are also electronegative atoms. So sometimes in compounds containing sulfur and chlorine also the hydrogen bond is seen somewhere. Am I clear? All the characteristics of the hydrogen bond are clear. The definition and the characteristics. Thank you. Good morning, everyone. This is second lecture on the topic the types of hydrogen bond. In the first lecture, we have seen hydrogen bond, its introduction, that is definition and characteristics. In the second lecture of hydrogen bond, we are going to cover the types of hydrogen bond. The hydrogen bonds are basically divided into the intermolecular hydrogen bond and intramolecular hydrogen bond on the basis of the fact that it is formed between the two molecules or whether it is formed between the same molecule. If the hydrogen bond exists between the two different molecules, then it is called intermolecular hydrogen bond. Like you have inter-college competition, where our university will fight in sports with some other university. Got my point? Next is intramolecular hydrogen bond. For example, the BSc students of this university are fighting against the BCom students of the same university. Got my point? So that comes under intramolecular hydrogen bond. So between different molecules, it is intermolecular hydrogen bond, and within the molecule, it is called intramolecular hydrogen bond. First, I am going to explain about intermolecular hydrogen bond. Intermolecular hydrogen bond exists between different molecules. I can show you the example of intermolecular hydrogen bond with the help of two types, that is homo intermolecular hydrogen bond and hetero intermolecular hydrogen bond. Homo, as the name suggests, means same molecule, same type of molecule. So here I have taken example of water. This is one molecule of water, this is another molecule of water. Between the two molecules of water, there is charge separation. How to show the charge separation? For example, the electronegative oxygen of the first water molecule is combining with the electropositive hydrogen of the second water molecule. So there are basically three water molecules, 1, 2 and 3. The first water molecule, oxygen, and the second water molecule, hydrogen. There is a special type of force of attraction between the electronegative oxygen and the electropositive hydrogen that is leading to formation of hydrogen. Similarly, between second and third water molecule. So this is existing between two different molecules, but the molecules are of the same type. I am repeating, this exists between two different water molecules, but they both are water molecules. That is why homo, and because it is between the two different molecules, that is why it is intermolecular hydrogen. Any doubts? Another example I can say ROH, that is alcohol. The electronegative oxygen of the alcohol is binding with the alkyl group of the alcohol. The alkyl group, for example, CH3, C2H5, methyl ethyl, they all give partial positive charge. So the partial positive charge of the second molecule is binding with the electronegative atom, that is oxygen of the first. Am I clear? So they all are same molecules. Water, 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 alcohol, alcohol, alcohol. That is why it is homo intermolecular hydrogen. Am I clear? Just opposite is the case of hetero intermolecular hydrogen bond. This exists between different types of molecules. Different types of molecules, minimum two varieties we have. The first variety is water, then alcohol, then water. So water is sharing its oxygen electronegative with the alkyl group of the alcohol. Second, the oxygen of the alcohol is being shared with the electropositive hydrogen of the water. So the bond, the force of attraction, the weak force of attraction which exists between the positively charged ions is the example of hetero intermolecular hydrogen bond. Another example I can take is ROH. What is this ROH? Alcohol. What is this ROR? It is ether. So ROH, the electropositive hydrogen of the alcohol with the electronegative oxygen of the ether. The bond between them will be intermolecular hydrogen bond, but between two different types of atoms, between two different types of molecules, that is why it is hetero intermolecular hydrogen bond. Same type of molecules, okay, homo intermolecular, and different types of molecules, hetero intermolecular. Clear? Next variety is intramolecular hydrogen bond. The major varieties two is the intramolecular hydrogen bond, as I have written, exists within the same molecule. Within a single molecule, there will be a force of attraction between the electronegative oxygen, fluorine and nitrogen, and that of the hydrogen. So I have taken two examples. The first example is of orthonitrophenol. At the ortho position, there is present the nitro group. So we have a nitro, which is NO2. This is alcoholic group of the phenol. So the electropositive hydrogen is bonding with the electronegative oxygen of the nitro. I am repeating. The hydrogen of the OH is binding with the oxygen of the NO2. But they all are the part of the benzene ring. That is why it is called intramolecular hydrogen. This is one functional group, this is second functional group. Between the two functional group of the same molecule, there is existence of intramolecular hydrogen. Second example I have taken is salicylaldehyde. Salicylaldehyde contains an alcoholic group and a aldehyde group. So the force of attraction between the electropositive hydrogen and that of the electronegative oxygen of the two functional groups, one is alcoholic and the other one is aldehydic, within the same molecule is called the intramolecular hydrogen bonding in case of salicylaldehyde. A quick brush up of the topic is intermolecular exists between the different types of molecules, okay, and intramolecular between the same molecule. Intermolecular are two types, homo and hetero. Homo within different molecules of the same type, hetero between different molecules of the different types. Am I clear? And these examples are important. You simply need to remember water, alcohol, your ether alcohol, water alcohol as an example, and in case of intramolecular, you need to remember two examples, that is orthonitrophenol and that of salicylate. Clear? Thank you.